So for the next example of the disk method, we're going to find the volume of the solid formed by revolving the region bounded by f of x equals 2 minus x squared, which is a downward parabola, and g of x equals 1, which is a horizontal line, about the line y equals 1. And there's really a great drawing in your book. If you want to look at that, it's on page 458. But we're going to just kind of try to sketch it over here so we can get an idea for what this is telling us to do. So first thing we're going to do is graph the parabola y equals 2 minus x squared. So it's going to have a vertex at 0, 2. I really should make this bigger. I don't know why I'm afraid to use the board. Okay, so at y equals 2, make it a little bigger. And x is 0. And then when x is positive 1, what is y?
1.
And when x is negative 1, y is 1. And when x is 2, y is negative 2. And when x is negative 2, y is negative 2. So what we have is this downward parabola right here. Okay, that's our first graph. So that's going to form part of our boundary of what we're revolving. Our second graph says we also want to bound g of x equals positive 1. So that would just be the line y equals positive 1. So I want what is trapped between them. So what I want is this little region right here. That is what I'm revolving. Are we good so far?
Yes.
Okay, and I'm going to take that region and I'm going to revolve it around this line. And you notice that it's flush with the axis of revolution, which is good. I'm going to revolve it around y equals 1. Okay, so what you do is and it's so much easier if you will just draw a rectangle. Draw a rectangle from here to here. And once you have that rectangle, we can sort of figure out what we need. Based on our formula, V equals, and because we have a horizontal axis of revolution, we're going to go pi from A to B of capital R of x quantity squared with respect to x. And so really the only thing you have to figure out are your A's and your B's.
So negative 1 and 1.
Yeah, it's going to be negative 1 and positive 1 for these, and I'll show you this the same way we would find that with area. If you're not sure how to find those, what you do is you take the two graphs, the top and the bottom, and you set them equal. 2 minus x squared equals positive 1. And so we have that won't work. Let's try it this way. Negative x squared equals negative 1, positive x squared equals positive 1, x is plus and minus 1. So that's how we got the negative 1 here to the positive 1 here. And those become your boundaries, limits of integration. Now we have to talk a little bit about how to calculate the height of this rectangle right here. So I need to know this guy right here. I need to come up with a formula that will give us that. And so we said that it should be, as long as we're flush with our axis of revolution, it should be the graph minus the axis of revolution, right, you guys? So our graph is 2 minus x squared, and our axis of revolution is 1. So capital R of x should equal 2 minus x squared minus our axis of revolution, which is positive 1. And that's as long as it's flush. As long as it's flush there. And that ends up being 1 minus x squared.
Yep.
Correct? That's what you're going to substitute in for R of x. So I'm going to pause in a minute and see if anyone has any questions about how we came up with R of x. Once we have it all set up, all we have to do is square this out, and we get pi from negative 1 to 1, and we need to FOIL this so that we can integrate each piece separately. 1 minus 2x squared plus x to the what? 4th. So just like with area, the integrals themselves are usually a lot easier to integrate than some of the stuff we've been working with. So we have pi, and then we have x minus 2/3 x cubed plus 1/5 x to the 5th. And then we're going to evaluate that from -1 to +1, remembering to multiply our pi by everything at the end. So we have pi times 1 minus 2/3 plus 1/5 minus -1 plus 2/3 minus 1/5. Because if I substitute a -1 in there, it would still be negative. Alright, then we just tally all of that up and see what we get. So I'll give you a minute if you want to calculate that for me. Make sure I didn't make any sign errors. So if we tally all of that up, we get 16/15 inside our bracket, and then it's multiplied by the pi at the end. So we really have a volume of 16 pi over 15 cubic units. We don't know what our units are, so we're not able to like actually put a unit on there, but it's cubic whatever because it is a volume. For the next example, we're going to find the volume of the solid formed by revolving the region bounded by the graphs of x equals 3y squared, x equals 0, y equals -1, and y equals +1. And we're going to revolve all of that about the y-axis. So this is going to be our first one that has y's in it. So first we need to get a good graph of x equals 3y squared. And I would like you guys to pay really good attention to this because you had some trouble on the previous quiz getting sideways parabolas graphed. So if we're going to graph x equals 3y squared. First off, if I let y be 0, what will my x be? Guys,
0,
x equals 3y squared. Okay, x would be 0. If I let y be +1, x would be positive.
3.
But if I let y be -1, x would still be positive.
3.
Look at that. And I think that's probably far enough because that's all we're going to graph anyway. It's from -1 to 1. So then we'll put those points on the graph and we have 0, 0, +3, +1, and +3, -1. So do you see that what we have here is a sideways parabola that looks like this. So this is the graph of x equals 3y squared. We're also going to bound that by x equals 0, which is this guy. So we have this graph, and now we have this guy, and that doesn't form a trapped region, so they're going to tell us what else to trap it between. And we're going to trap it between y equals -1, right here, y equals -1, and y equals +1. So what we're actually taking is this area right here, and right here, and we are spinning it around the line x equals 0, which is our y-axis. So notice that that is flush with the axis, and so we can use what we call the disk method, right? Okay, and so for each little piece, do you see what kind of shape it would make if we spun that?
An hourglass.
It would sort of make an hourglass shape, right? Because it would come like small in the middle, except it would actually make almost really nothing in the middle, you know, and
Yeah.
it would be like basically like two,
Triangle things.
yeah, like two, it would look like
Circular.
a spool almost, but not a lot of space in the middle. You know what I
Yeah.
mean? Where the tops are so much bigger than the midsection there. Okay, but it is very hourglass-like as well. Okay, so we're going to set up our formula. V equals pi times the integral from c to d of r of y quantity squared with respect to y. So the volume is pi times, and then notice that the y values where I'm stopping and starting are -1 to +1. So this is your c, this is your d. And then to find this time your rectangle has to go this way. So your representative rectangle goes this way. So we're going to subtract the two like edges here. So this is our 3y squared right here minus this guy. So So top and bottom of our rectangle, which is just 0. And that's going to be your R of y. It is your graph minus your axis of revolution because it is flush. So that gives us 3y squared minus 0. And then we're just going to square it. And then we can integrate it and substitute in our limits of integration. So we really are integrating pi times the integral from -1 to 1 of 9y to the 4th. All right, what next? Go ahead and integrate. Now, do you want to pull the 9 out, or do you want to just leave them in? It really doesn't matter.
Pull it out.
Huh?
I pull it out.
You want to pull it out? Okay. So if we pull the 9 out here with the pi, we have 9 pi times the integral of -1 to 1 of y to the 4th. And then that would integrate up to 1/5 y to the 5th. So I'm going to show you a little trick and see if you understand it. 1/5 y to the 5th. If you can, I don't need the dy anymore. If you can go ahead, if you want, see how the 1/5 is with everything? You can bring him out here as well. So that actually make your numbers a lot easier. You would have 9 pi times 1/5. And all you have to really worry about evaluating is just the y to the 5th. Now that doesn't work if you have binomials, but if it's a monomial, you can bring all of your numbers out and only substitute the 1 and the -1 into the variable portion. So if you want to do that. So we have 9 pi over 5 multiplied by 1 to the 5th, which is 1, minus -1 to the 5th, which is
-1. Right.
-1. And that ends up being 1 plus 1, which is 2. So really I have 9 pi over 5 multiplied by 2, which would be 18 pi over 5 cubic units of volume for that hourglass shape.